Let's draw a Venn diagram for two sets and then talk about those operations that we've been looking at. So I want to draw the Venn diagram for these sets. First I've got my universal set, which is a set of all x, such that x is a natural number, or is a member of the natural numbers, and x is less than or equal to 10. So this is all 1, 2, 3, and so on, up to 10. My set A is 2, 3, 5, 7. My set B is 1, 3, 5, 7, 9. So to draw a Venn diagram, the first thing I want is some space to put everything in. So this will be my universal set, or this whole rectangle is my universal set. Then, since I have two sets, I need to draw two circles, and come on, IntelliPen. Yeah, that's not good. Give me a nice circle. Okay, so since I have two sets, I need to draw two circles, or at least kind of round-looking objects, and I want them to overlap. Even if I know that these two sets have nothing in common, when I draw them overlapping because it doesn't hurt anything to do so. I'm going to label this set Set A, and this set Set B. Now, to fill in this Venn diagram, the first thing I want to do is look at A and B and see what do they have in common. So I see that they both have 3, 5, and 7. So I want to put 3, 5, and 7 in this middle space. That's because that middle space is in both of those circles. 3, 5, and 7 are in the circle for A. They're in the circle for B. That means that 3, 5, 7 are in this space in the middle here, because that's where the circle for A is and the circle for B is, where they overlap. Okay, after that, I usually just go out and say, well, I don't have this number yet, or this element yet, so I'll put that here in A. Now I'm done with A. A has 2, 3, 5, 7. That's what my list tells me it's supposed to have. Next I go out to B, and I say, what don't I have here yet for B? Well, I don't have 1. I've got 3, I've got 5, I've got 7. I don't have 9. So B has 1 and 9 in that space. So now B has all of its elements, 1, 3, 5, 7, and 9. And the last thing I do is I say, what am I missing from the universal set? This universal set's pretty nice, so I can just kind of count. I see 1 over there in B, 2 is in A, 3 is in the middle, but I'm missing 4. 5 is in the middle. I'm missing 6. 7 is in the middle. I'm missing 8. 9 is over there in B, and I'm missing 10. Here's the Venn diagram for those sets. Universal set, all the natural numbers less than or equal to 10. A is the prime numbers less than 10, so 2, 3, 5, 7. And B is the odd numbers less than 10, 1, 3, 5, 7. Here's how those guys all interconnect, or what their Venn diagram looks like. I want to take a second and just talk about those set operations. A intersect B, remember, is all of the elements that they share. And in fact, those are the first ones we found. We said, what do A and B have in common? That's what I need to put in the middle of that circle. So 3, 5, and 7 are in A intersect B here. And that's the stuff that lives right here, right in the middle. These are the pieces that are in both, so that's what's in their intersection. Okay, let's look at the union. A union B is everybody that's in one or the other or both of these. So I can either look up here and say, well, A has 2, 3, 5, 7, B has 1, 3, 5, 7, 9. Or if I'm looking for the union and I have a Venn diagram, I can just look at everybody inside of this space. Those are all of the elements that are in either A or B or both. So A union B is 1, 2, 3, 5, 7, 9. 1, 2, 3, 5, 7, 9. That's what's in their union. Another thing that I can find from a Venn diagram pretty easily, remember, is the complement. Let's say that I wanted to find B complement. Well, recall that's everybody outside of B, everything in the universal set that is not in B. So if I want the complement here, I'm looking for any of the elements that are outside of B, which would be 2, 4, 6, 8, and 10. So B complement, everyone outside of B is 2, 4, 6, 8, 10. Hopefully that shows you a little bit about how I can use a Venn diagram to find some of these operations, and there you go.